Hi everyone, let's talk about inverse functions. An inverse function is a special kind of function that has the following relationship. Basically, f and g are inverses if f of a equals b and g of b equals a for all a and b in their domains. Now specifically what that means, if, for example, if I take a look here, the graph of f of x has the ordered pair 0, 2. This means that the graph of g of x should have the ordered pair 2, 0. Okay, likewise, another one easy to pick out, the graph of f of x appears to have the ordered pair negative 1, negative 1. And since negative 1 and negative 1 are the same value, when you swap them, you should get the same result. So basically, in order to find an inverse, you want to check this property that they reverse each other. So again, for example, if a is sent to b via the vehicle of the function f, then the function g would send b back to a. Okay? Now if you think about our compositions for just a moment, this means that if I were to do f of g of b and follow my chart, g of b is a, f of a is b, so they essentially undo each other. Okay? Likewise, g of f of a would become g of the value b, which the function g in red takes b back to a, so yet again they undo each other. Okay? Alright, so a common technique for finding the inverse of a function, and I'll clarify in a moment when the function has another function as its inverse, is basically the thought process is to switch the ordered pairs. So switch x and y and then solve again. For y. Okay, so we'll discuss this as we continue through the examples. Alright, now many times if we say that notice that g of x passes the vertical line test. So what we want here is to start with a function and end up with a function in order to call it an inverse function. Okay? So when would this not work out? Well, for example, if I take something like y equals x squared plus 1 and exchange all the x and y values, I go from having an upward opening parabola to a parabola that opens sideways from left to right, and there's still the commonality here that this graph has the point 0, 1, so therefore when you swap x and y you should have the point 1, 0, and that's indeed true, ordered pair by ordered pair for both graphs. The problem is once you swap x and y, the bright green graph, which is now the one you're considering to be the inverse relationship, fails the vertical line test, which means it's not a function, or not the graph of a function. Okay, so what is it about the original guy, y equals x squared plus 1, that lends itself to producing a new graph when I swap the ordered pairs that isn't a function? So let's think about that for a moment. Okay, so notice what happens here. With the graph of y equals x squared plus 1, every y, except at the vertex, backs up to two different x's. So that means that when you swap coordinates, every x, except at the vertex, will have two y's, and that's why you fail the vertical line test. So we say a graph like the pink parabola fails the horizontal line test. So if you have a function whose graph fails the horizontal line test, then when you swap all of the ordered pairs, the resulting graph will fail the vertical line test. And in that case, we do not say that that's a function, so we don't refer to that as an inverse function. Okay? Alright, so if you fail the horizontal line test, the specific terminology we use is that the function is not one-to-one. Now, one-to-one means this. If I take one x coordinate and got one y coordinate and one y and got only one x, that's what we call one-to-one. And this guy fails that property. So one-to-one functions will have inverses in the sense that we mean, meaning that we produce a function. Okay? I hope that makes sense. Now also I want you to notice in both cases, whether or not you produce an inverse function, or if we go back to our original, these two guys were inverses. And I want you to notice that if you swap every ordered pair A, B and get the ordered pair BA, you are naturally creating symmetry about the line y equals x. So you want to start with a function and end up with an inverse that is also a function. And when you swap x and y, you end up with symmetry about y equals x.